Section 13.3 Geometric Sequences, Part 4. Find the partial sum of the geometric sequence that satisfies the given conditions. Okay, so find the partial sum. When n is 4, we want to find S4. That would be the sum of the first 4 terms. Okay, here's our formula for partial sum. So we're just ready to plug in. If we look at A is 2/3. So we have 2/3 here. Okay, then we have 1 minus R, which is 1/3. 1/3 gets raised to the 4th power, all over 1 minus 1/3. Okay, so anytime we have add or subtract, we cannot cancel anything in between the division sign. This gets treated separately. Numerator, this keeps separated. Denominator, but our calculator can help us get to a nice answer. Okay, so let's take 2/3. And we're going to multiply that by, okay, so I'm going to need an outer parentheses for the whole thing, but then I'm going to need an inner parentheses, one for the numerator, one for the denominator. Okay, so this is going to be 1 minus, then we're going to take 1/3. We're going to raise that to the 4th power. Okay, so there's my first numerator. Now we're going to do the second, which is the denominator. 1 minus parenthesis 1/3. Okay, so there's a set of parentheses for the numerator. There's a set of parentheses for the denominator, and then a set of parentheses for the whole thing. And I think we're ready to calculate. Just in case, I'm going to say answer in fraction if the fraction appears, and it does. 80 over 81. 80 over 81 would be our solution. Okay, so 80 over 81 is our solution. Let's go on to that next example. Find the sum. Okay, so pretty vague, but at least we do know that it's a geometric sequence, so we can use our geometric formulas. We're looking to find the sum. We're not finding the sum of an infinite series, we're just looking at the sum of a partial series. So here's the formula that we're going to use. What we're going to need to know, though, is n. How many terms are appearing in the sequence? We know the first term, A, the first term is 5120. We're also going to need to find an R. Let's see if we could look at finding that n and the R needed in order to do a partial sum. Okay, I'm going to start with AN is equal to A times R to the n minus 1. Why I want to start here is because I can probably figure out n and r from this formula. Okay, so we know A is 5120. So if I put that in here, we got 5120. I can figure out r, because remember r is I'm going to divide a right term by a left term. If I divide that right term by the left term, I can figure out what r is. So let's take 2560, and we're going to divide that by 5120. Let's take 1280, and we're going to divide that by 2560. We keep getting the same 1/2, and so there's our common ratio. Okay, so we know now our common ratio is 1/2. What we're trying to then figure out is what n is. Okay, so what we could do is we could, let's see, if this is the first term, this is the second term, we could call this, which it is, the third term. And so here we know n is 3. So if I plug in a 3 for n, then what comes out when n is 3 is 1280. So I can put that in here, and I can solve for n, but by doing so, notice that we don't even have a variable to solve for. I can do a quick calculation and I would get this answer, but that doesn't give us a variable. So let's reconsider this. If I want to look at a variable, maybe we should do this. Let's go with an. Okay, so if I know an is 20, I can put that into here. So we have 20. I know the first term is 5120, so we can put that into here. We found out that r was 1/2, so that's still good. But now we don't know n. We just know an is 20, but we don't actually know what n is exactly. So let's go ahead and fill in our n minus 1 for our power. Okay, let's divide over 5120. If we take 20 divided by 5120 and put that in the fraction, we get 1 over 256. And here we have 1 over 2 to the n minus 1. This power, because this is division, this power can be taken to the numerator. 1 to any power is 1, and to the denominator. That was our property of exponents. Okay, do I know what I can take 256 to? 2 to what power is 256? Let's experiment. 2 to the third we know is 8. 2 to the fifth is 32. 2 raised to the 7th is 128. 2 raised to the 8th is 256. So let's look at rewriting 256 as 2 to the 8th power. And then this is equal to 1 over 2 to the n minus 1. So what do we know n has to be? N would have to be 9. 9 minus 1 would give us 8. All right, we're ready for our sum, the nth partial sum. We're adding up the first 9 terms of this sequence. So we have a, which is 520. That's our first term. Then we have 1 minus r is 1/2. So we're going to take 1/2 and raise that to the 9th power. That's going to be all over 1 minus 1/2. Okay, so let's get that put into our calculator. We'll let the calculator do the work. So we're going to take 5120. We're going to multiply that by, so I need an outer parenthesis, and then I need 2 parentheses inside, a set of parentheses for the numerator, a set of parentheses for the denominator. Okay, so for the numerator, we have 1/2 minus, I'm going to just say 0.5 because that's what a half is, 0.5 to the 9th. Okay, so there's our numerator, 1 minus 0.5 to the 9th. Okay, we need another set of parentheses for the denominator, which is 1 minus 0.5. So there's our set of parentheses for the denominator, and then we have a parenthesis for the whole thing. Just in case, I'm going to end this with answer in fraction. Didn't need it, but that's okay. Our sum of the first 9 terms is 10,220.